Algebra 2, Lesson 27 is about rational expressions. Okay, rational just refers to something that can be written as a fraction, as a ratio. Okay, so these are written as fractions. And as you can see in these examples, we're going to be adding and subtracting fractions. Okay, so I started out with this sample problem up here to remind you how we do this when the whole thing is written in digits, when there are no variables included. In order to add or subtract fractions, the denominators must be equal. It has to be equal pieces. All right, so you could take 56 over 56 times this first fraction and 40 over 40 times the second one, but you would definitely have to reduce at the end. In order to keep things simpler, smaller, easier to work with numbers, we prefer to use the least common multiple of those denominators, so the lowest common denominator. Okay, so in order to do that, I'm looking at 40 and I see that that is 5 times 8, and 56, that is 7 times 8. And so 8 is a common factor to both of them. If I just multiply this 40 by 7 and multiply this 56 by 5, then those denominators would be equal. 5 times 7 times 8. So instead of really big numbers by multiplying by 56 and 40, I'm just going to multiply this one by 7 over 7. Then we have 7 times 5 times 8 in our denominator. And this one times 5 over 5, because again, 5 times 7 times 8 in the denominator, so that they will be equal denominators. Okay, so that means we have 21 plus 55 over that common denominator, which looks like that would be 40 times 7 is 280. Okay, and then we add the like terms in the numerator, and that looks like 76 over 280. And then I also see that this reduces. 76 and 280 are both even, so I know it'll at least divide by 2. I also notice these are both going to divide by 4, so I think I'll do that. And that would be, dividing this by 4, I think is 19. Yeah. And dividing that by 4, we're getting 70. And then that's it. It won't reduce any further. So that would be our answer to that. But we first, anytime we are adding any fractions or subtracting them, the denominators must be the same. So we do that first. Then we add or subtract, as indicated, the like terms, and then simplify. So, of course, now we're going to have variables in these problems, but they work the same way. These variables are standing in for numbers. They follow the same rules. All right, now I also see a sum in this denominator, and any time a factor of any of these denominators is a sum, that whole sum has to be a factor in our LCD. So I'm just going to make a note of that over here. When one of the denominators, or both, when one of the denominators, get that on the screen here, has a factor that is a sum, then that sum must be it is one of the factors of the LCD, the least common denominator. Okay, so I know x plus a has to be a factor of our denominator. Basically what we're going to do is take x plus a over x plus a times this first fraction and x over x times the second one. Now here we're distributing this 4, so it's 4x plus 4a, that's all from this part, 4x plus 4a, plus 6x, all over the common denominator of x times x plus a, which I'm not distributing. Okay, later, whenever, like at the end of the one with numbers up top here, we reduced at the end. In order to see if this will reduce, I want to keep this factored. Okay, so now in the top I do have like terms. 4x plus 6x equals 10x. So 10x plus 4a in our numerator, and then the denominator is x times x plus a. There is no way I'm going to factor the numerator and have that a factor of this is x or x plus a. So I know this will not reduce. That is my final answer. Alright, it's the same process as if they were numbers, because again, variables are just standing in for numbers that are unknown. Okay, so in example 2 we have three terms that we're adding, and they need to have the same denominator. When you have just, this is not a fraction, you can put that over 1. Okay, and so I see a sum here again. X plus 4 will be one of the factors, and so will x squared. So I need to take, I think I'm going to have to rewrite this one. I didn't leave, there's not enough space in here to write what I'm multiplying times the 6. So for the first one, well, we're going to take x squared over x squared times that, and x plus 2 over x plus 4 plus. Now, this denominator right now is only 1. We have to multiply the x squared and x plus 4 times this one. So we have 6 times x squared times x plus 4. X squared times x plus 4 plus 2 over x squared just needs to be multiplied by x plus 4 over x plus 4. And then we have some distributing, and then probably some like terms to add. So for the first one here, we have x squared times x, that is x to the third, okay, plus 2x squared, plus, now I have 6x squared times x, so that's 6x to the third, and I have 6x squared times 4, so plus 24x squared. Okay, so these two are from the middle term. And then plus 2 times x, 2x, plus 2 times 4, so 8. And all of that is over my common denominator of x squared times x plus 4. And now I add like terms. Okay, so we have here 7x to the third, and then x squared, 26, 26x squared, okay, x to the third, x squared, plus 2x plus 8, all over x squared times x plus 4. Okay, and I know that I cannot factor an x out of the numerator because this 8 doesn't have an x as a factor. And this also, x plus 4, will not be a factor of the numerator. So again, that's all there is to do. Get common denominators, distribute, add like terms, and then see if it will simplify. Okay, now for this next one, we are going to be doing a little factoring first. Okay, this is one of the reasons I showed you that example at the top of the page with 3/40ths and 11 over 56. Finding the least common multiple involved looking at the factors of those denominators. This factors. Okay, we're going to reverse FOIL this. So I'm just going to write it under here, I think, for now. Okay, this is just for the denominator. X squared means I have an x in the beginning of each of my set of parentheses. I need factors of 3 that add up to 4. Well, there's only one way to factor 3. It's 1 and 3. Okay? They both have to have the same sign because of this plus. That sign has to be positive because of that middle term being positive. And so if I FOIL what I've written here, I should get that denominator. X squared plus 3x plus 1x is plus 4x, and then plus 3. So this original problem could be rewritten x plus 2 over x plus 1 times x plus 3 minus 1 over x times x plus 1. And now I'm looking for the least common denominator, and I see they both have a factor of x plus 1, so I'm not going to have to multiply either of them by that. This one has a factor that is just an x, and the one on the left does not. So we're going to multiply x over x times this one, and then see my denominator is x. They both have that. Times x plus 1, they both have that. Times x plus 3. So the one on the right needs x plus 3. Okay, now they have the same denominators, and I can go ahead and multiply. Now this x plus 2 in the numerator, I'm putting in parentheses because that whole numerator is getting multiplied by this x. I have to distribute this x. So, x times x, x squared, plus x times 2 is 2x. Okay, now I need to be careful with this next one because of that minus. Everything in this next numerator is getting subtracted. So, for now I'm just going to write it in parentheses. Okay, so there's my minus. Now this whole numerator will be in parentheses. It's just x plus 3 because 1 multiplied times that. Okay, that whole numerator now is over x times x plus 1 times x plus 3. And now, this is basically a negative 1 that we are distributing here. Okay, so this is equivalent to, we'll go here just to make sure I have room, x squared plus 2x minus 1x minus 3, because I have negative 1 times a positive 3. And it's still over this denominator. Alright, I add my like terms. X squared plus x minus 3 over x times x plus 1 times x plus 3. Okay, now I do need to see if this reduces, and this looks like a thing I might be able to factor. So let me just check that out real quick. Okay, so there'd be my x squared. The only way to get a 3 is a 1 and a 3. And I'm going to have to subtract them, but 3 minus 1 is 2. I'm not going to be able to get a 1x for my middle term. So I know that's not possible. That doesn't factor. Therefore, this won't reduce. That's my answer. And that's all we've got for lesson 27. So I hope you have fun with these.